Hello friends, in this video we are going to discuss about the cash flow diagram, single payment method and equal payment method. Okay. First we discuss about the cash flow diagram. It is a graphical representation of the cash flow, that is both cash flow that is outflow or the inflow with respect to a time scale is generally referred as the cash flow diagram. So in this diagram you can see this is the cash flow diagram. We generally call this as the cash flow diagram. Here for vertical direction arrow, it is indicating the cash flow, it was inward flow, that is a person has gained from the cash, right, or he has taken he has got that much amount of value, amount or money. And outflow is person is spending the amount, or a person is giving to the some other bank or some other person, right. This is the direction of arrow which is showing at the bottom downward direction, vertically downward it shows the cash flow outflow, and vertical upward it shows the cash flow inflow, and horizontally scale it is showing the time scale, that is the interval interest time, right, interest time period of, right, 1 year interest or 2 year interest, yearly interest rate, or sometime it may consider as the monthly interest will be there, or in some cases quarterly interest will be getting. So depending upon the interest time, depending upon that it will be it can be calculated, considered as the yearly or monthly or a quarterly. So in this cash flow diagram you can see bottomwards it is 1 lakh rupees, that is at the zero. It means at the 0th year a person is invested in a bank or deposited in a bank, right, at 1 lakh rupees, and next first year, second year he has not did anything, right. In third year a bank has given 35,000 rupees for him, right. Again at the end of the fourth year he has given the 15,000 rupees, or he has deposited it, and again in this sixth year he has got the 80,000 rupees, or he has borrowed it, it is 80,000 rupees, and after the seventh year he has got made the payment to bank or invested in 25,000 rupees, and at the end of 10 years, right, he has bought 45,000 rupees. So this is how inflows and outflows are mentioned at the year-wise basis. In any transactions or any of the cash flows are considered within the intermediate times, it's generally considered at it will be indicated at the end of the year itself, because it will be for better calculation, and it will be ease of calculation, it will be considered at the end of that year or a particular interest time, right. This is how it will be cash flow diagram, it will be considered here, right. So again this is all the same thing what I have explained, right. Next we see about the compound interest factor. Okay, the compound interest factor and the corresponding formulas are used to find out the unknown amount of a given interest rate continued for a certain interest period from the known value of varying cash flow. So here what will happen, compound interest, here we are going to calculate the amount to be considered for a certain period, or amount here are some formulas to calculate the amount at certain intervals. If I want to keep the money for in a bank, or if I want to invest every year for a certain amount, fixed amount, and with a certain rate of interest. So what will be my future amount which I am getting at the end of the at the end of the certain known period. So that those all compound interest and everything it will be calculating using the following formulas. So in this these are the some notations we have to follow. P is the present worth or the present value of the money. Okay. So next F is the future future worth or the future sum, that is after a certain year what will be the total amount of the present worth money. Okay, A is the uniform annual worth or equivalent uniform annual worth is to be series. So that is if I say that every year I am going to invest in a bank for about 5,000 rupees, so in that case, so that after certain 10 years, so I am getting the at an interest period of 5% or 10%, I am getting certain amount of year final amount. So in that whatever the after 10 year amount I am going to get, so that amount we will consider as the future amount, and the 5,000 rupees which I am going to consider for a year continuous I am going to paying, so that we consider as the uniform annual worth. And N is the number of interest period as I said that 10th year, so I is what here the rate of interest, I is here what rate of interest, okay, period, that is it can be considered as the per year, or it may be considered as the per month, or it can be considered as the quarterly of both. So anything can be considered depending upon the nature of the investment or nature of the bank, right? So here depending upon this interest period, so here N will be considered as the a number of years or number of months or number of quarters. Depending upon this it can be varying. So here unless otherwise stated, rather stated the rate of interest is computed compound interest and is for the entire number of interest period, that is for the n interest period. So here we have to it will be finally stated that it should be known interest should be present, and for the known number of interest period has to be considered. So here this in this graph or in this cash flow diagram we can see that P, that is the present worth here at the first investment, that is my P, okay, present worth amount, and these are the small intervals at the every interval of the annual worth. So whatever we are keeping in the bank, so that will consider as the uniform annual worth, and F is the future worth. At the 6th year I am getting certain amount of money from the bank, and at the 10th year I have got the certain amount of money, okay, and A, as I said, that it is a uniform annual worth money, okay. So this is how your cash flow diagram can from the cash flow diagram we can represent the amounts which is generated, okay. Next, in this figure the present P is the beginning amount or a uniform annual series worth of annual value A is formed at the end of 1 year 1 to year 5. Both P and A are the cash outflows because a person is investing in a bank at every year from the from the start of the 0th year to the end of the 5th year, right. It may be noted that the from uniform annual series worth series with the annual value A may be also be continued throughout the entire interest period, that is from the beginning till the end of the 10 year, or for some intermediate interest periods like commencing from the end of the 3 till the end of the 8th year. So anything can be considered from the beginning at the 0 to 10th year, or from the intermediate period like 3 years to 8 years. Anything in between that we can be considered. The future worth, that is F, is occurring at the end of the 4th year, cash flow out at the end of the 6th year, and at the end of the 10th year, that is cash flow in. So this is how we can be bifurcated the cash flows for the future worth, okay. Next we are going to see about in this how we are going to consider the single payment compound amount factor. So there are different formulas to calculate this compound amount. which we are discussing in the earlier diagram, right? So here in this single payment compound amount factor is used to compute the future work F accumulated after the n years from the known present work P at a given interest rate I per interest period. So here what we are going to consider, what we are going to find, we are going to find the what will be the future amount worth. Okay, for example, if a person want to invest the money at a yearly basis in a bank, so that for about amount 10,000 rupees for a duration of 10 years, right? If he invested and interest rate for that 10,000 rupees per year, it will be 16, say 10% or 15%. So we go with the 10% per year, right? At the end of the 10 years, how much amount he can get using the compounding, because compound means what? Well, whatever this 10% interest it is there, it is going to apply for the whatever the interest is generated from the next commencing year, right? So in that case, so what will be the last total amount at the end of the 10 years? It can be calculated from the single payment compound amount factor, right? It is assumed that interest period is in years and the interest is compounded once per the interest period, right? So here the known present worth, we have the known present worth, right, and the uniform future worth F, and the total interest period N are as shown in the figure C here. P we have no end of the year 1, 2, 3 to n times, so we can consider any of the value 10 years. So in that case n becomes the 10. At the 10th year, how much the amount future unknown value it is there, so future worth it can be calculated. So using this formula, that is F is equal to, that is the unknown value, that is future amount is equal to P is the present value into bracket 1 plus I raised to n. I is the rate of interest and n is the number of years. So here the 1 plus I raised to n is a factor, is equation is known as the single payment compound amount factor. So this factor will consider as the single payment compound amount factor. Okay. Next is single payment present worth factor. So here what we are going to consider, the single payment present worth factor is used to determine the present worth of a known future worth at the end of the n years at the given interest rate of I. So here, what in the previous example what we are doing, we know the present worth, that is what amount we are going to keep in the bank. So what amount we are going to keep in the bank for a certain period, that is 10 years. But here I don't know how much amount I have to be paid at every end of the every year, but I know at the end of the 10 years I should get 1,50,000 rupees. So example, take an example, at the end of I know here 5 future worths, but I am going to calculate the present worth. So how much amount has to be invested in a bank, so that I can get at the end of this certain year so and so amount can be calculated, or at the end of the 10 years I can get the 1,50,000 rupees from the bank. So with using the certain rate of interest, say it may be of 10%. So using this function I can calculate the present value. I know the future value and I don't know this one, but I know the future value, I know the number of years and I know the rate of interest. So using this I can easily calculate the present value. So how to calculate? Using this formula, P is equal to F into bracket 1 divided by 1 plus I raised to n. So this is the same formula which we have calculated in the which you have seen in the previous this one. So, but here what we did, we have taken this which is here, it came here at the bottom denominator, so that it will become to calculate the p value, right? Again, same calculation, same simple mathematical calculation it is there, we can easily calculate it. I is in terms of percentage, so I have to consider if it is a 10% it is there, we can write it as 10 divided by 100 or 0.1 like this. Okay. Next is uniform series present work factor, or we can also call it as equal payment series, equal payment methods, right? In this equal payment series compound amount, I can also call it uniform series present work factor. So here the uniform series present work factor is used to determine the present work of a unknown uniform series. So here what we are going to calculate what will be the present work from the unknown uniform series. Okay. Let A be the uniform annual amount at the end of the each year, and the beginning from the end of the year 1 till the year n, and the known A and unknown P and the total interest period n years are shown in the figure. What I have said, a known A, I know the how much amount that every month has to be fixed, and I don't know the initial amount, right? Or I can say that present work factor I don't know, and I know the total interest period at certain, you can consider 10 year, 20 year, 15 year, and along with this interest rate, that is 10% per year, 5% per year, 20% per year, right? We know this. So here what we are going to calculate, if I invest certain amount P, that is initial amount, or we can also call this as the present worth, right? So how much amount it can be generated at the end of 10 years, so that I can get. So here the cash flow diagram refers to case if a person wants to get the known uniform amount to be written at the every year, how much he has to invest now. That means if I invest a certain amount here, so that I can get at every year a fixed amount rate at the end till the end of the certain year, or the fixed year, nth year. So this is how our uniform series present work factor is working. In the previous what we are going, we are investing every year and we are getting the total amount at this final year. But here what we are doing, we are investing at the only at the first year itself, or the zeroth year, and after that every year I am getting the income from that till the nth year. So that's what we are going to calculate, right? Here the present work P of a uniform series can be calculated by the considering the each A of uniform series as to be further work. So this is the formula, we can, using this we can calculate P is equal to A, that is the unknown at every year we are going to getting, right? And 1 plus I raised to n minus 1 divided by I into 1 plus I raised to n. So the factor within the bracket is the equation is known as the uniform series present work factor. Uniform series present work factor. Thus, if the value of A in the uniform series is known, then the present work P at the interest rate I per year can be calculated by multiplying the uniform annual amount A with the uniform series compound amount factor. So by multiplying this A with knowing I and N, we can easily calculate this one P, that is the present work value. This is how we can calculate. Next is capital recovery factor. So here capital recovery factor is generally used to find out the uniform annual amount A of a uniform series from a known present worth at a given interest rate. So what we are going to calculate here? We are going to calculate the A value, uniform amount, how much I can get if I invest a known value of P at a certain known value of the interest period along with the interest rate. So here in this cash flow indicates the if a person invested a certain amount now and how much he will get as a return by an equal amount each year. So in the previous case we are not knowing the present worth, so how much to invest, but in this case we know the how much amount I am investing, but unknown is how much amount he can get back from every year interval. So that's what we are going to calculate using the formula A equal to P into bracket I into 1 plus I raised to n divided by 1 plus I raised to n minus 1. So this is the same as in similar to previous formula. Just what he has taken at there P was here and A was multiplied A into 1 plus I raised to n minus 1 divided by I into 1 plus n. So what he has is here unknown was A. So this compound will be taken here and this compound which was here it is taken here and inverted. So it is the simple mathematical formula. Using this we can easily calculate the unknown value or the uniform amount to be uniform annual amount which can be getting from the end of every year. Next is uniform series compound amount factor. Here the uniform series compound amount factor is used to determine the future sum F, that is future sum of a known uniform annual series with the uniform amount A. That is here we are going to calculate the final end amount if I invest certain in a same amount at a interval of this one. So here in this cash flow diagram states that if a person invests a uniform amount at the end of every year continued for n years at an interest rate of I per year, how much he will get at the end of n years. So what he is knowing? What he is doing? A person is knowing the amount to be invested at the end of every year and he should know the time span. So if a person is investing in a bank for at the end of every year as a 10,000 rupees till the end of the 10th year, 10 years. So he is going to what he has to do? He has to just invest 10,000 rupees till the 10 years, right, up to 10 years, and once this 10 years is completed, how much amount he is going to calculate, how much he is going to getting from that. So that we are going to calculate, that is the final worth of the amount. So here the factor in the bracket is equation is known as the uniform series compound amount factor. So this is using this we can easily calculate the value of the final value of the amount. Okay, and next is sinking fund factor. Sinking fund factor is used to calculate the annual amount A of a uniform series from the known future sum. So here unknown is this one, how much amount I want to invest, I don't know, but here I know, what I know is what should be my end amount, what should be my total amount I am going to get from the end of last year. So here this is how, using the formula A equal to F into bracket I divided by 1 plus I raised to n minus 1. So this is how I can easily calculate. So this is the chart. In this we are having all the formulas to calculate and all the name of the factors which are interest factor with the rate of interest I and the number of interest period N. Using this, these are the table we can calculate, and these are the abbreviations we are using for the all the different terminologies, and functional representations we can also consider this as the functional representation for each and every one, and these are the mathematical expressions we are using. And here given values, this is for first single payment method, it is P. The second is the single payment present work method. Here we know the value of final worth amount. Uniform seed is present. Here we know the known value of every month which you are going to add. And P, it is the initial capital amount which you have to invest. And so these are all the given data, and these are the unknown factors we can be easily calculated by multiplying 5 with the fourth column. So I can easily calculate the F factor. So this is how we can calculate the interest factor. Okay, you can go with the textbook so that you can get the simple problems, so that you can solve easily using the simple mathematical problems. Okay, thank you.